color, a topic so complex only understood by a few hundred people globally. However, in science, it can be explained by three things: temperature, reflectance, and absorptions. Now, this blue shirt I'm wearing isn't blue at all. It only appears blue because it's reflecting blue light. It is absorbing every color of the rainbow, every color in the color gamut except blue. Same thing with the plant. It is everything but green. It is absorbing every wavelength of light and reflecting green. Now, this can be very easily done by taking a glass prism and putting it in the sun. And you'll notice that it will deflect the light and you'll see a rainbow. And it works by light entering, splitting, and exiting as its original colors. Now, the thing about light color is that when you add colors in light, you get a lighter version of that color. If you took paint colors like acrylic paint and you mixed more and more and more together, it would start to turn a brown black, but not light. Now, the goal of this project was to create a wick that could change colors. And there is one major flaw in this, and it is that the wick needs to be wet to work. Although a wet wick doesn't light, and here's why. So, this would physically work using a stipple standard wooden wick. Now, a woolen wick wouldn't work either because it has a wax coating. So if you were to soak it, it still wouldn't light. That woolen wick with the wax coating wouldn't absorb any of the chemicals. Now, the two chemicals that were used in this project were strontium and copper nitrate. So let's go back to this problem. By soaking it in a solution of copper nitrate, you can get the color green. So if we just dip that in there real quick, pull it out, light it on fire, there's still a propellant in here. You'll see that it shoots green flames. But it doesn't stay that way. So I didn't dip the flame over here. So let's light that part. You'll notice it's not catching at all. It's just smoking. But why? And here's the fall of this project, is that every accelerant used is going to evaporate. Any type of grain alcohol simply wouldn't work. Even gasoline, not only could it put off bad fumes, but also evaporate much, much faster. So let's introduce another problem, is that when the accelerant evaporates, there's nothing there to keep it going. So by now, the wood has already dried up. Let's try this again. It doesn't light, but it lit before with all of that alcohol in it. And here's the problem, is that it's just sitting on top of the surface. It's not actually soaking into the wood. And when the accelerant ran out, it wouldn't light, as we saw previously. The same thing happens with the red colored flame. It's just a different chemical. So now let's talk about chemicals. Have you ever seen the inside of a copper pipe? Well, the inside of a copper pipe is green because it's oxidized. And that's exactly what's happening here, is that the flame is reacting with the air and causing it to oxidize, giving it the color green. That is why when this wick burns, we see the green flame. When strontium oxidizes with oxygen, it becomes a red flame. So, to make this project better, or to make it actually work, there would need to be one upgrade, and one upgrade only. And that would be figure out how to chemically bond these elements with the wood.